Welcome to yet another episode of Intech Online Technology News. We discuss tomorrow's technology on this channel. And today we are going to talk about a very different subject. We just published a news on what is the life of plastic, how long the plastic will last. I'm sure all of you would have seen if there is an old rubber band, it suddenly snaps. Or there's a plastic toy, it gets brittle and it cracks. And scientists have identified that there is some hidden countdown clock triggered by heat and air. So today we are going to look at this, how scientists finally figured it out, how to predict exactly when your everyday plastic items will expire. And in this episode, we are joined by Dr. Deshpande, who is Professor of Material Science at COEP Technological University, Pune. In this episode, we will talk about how heat and air affects the plastic from inside out, how plastic stays strong over the years, how do scientists use some test to identify when the object will fail, and last and most important, the careers in material science and plastic technology. So welcome, Dr. Deshpande.
Thanks, Anand.
So here goes my first question to you, Dr. Deshpande, and it is something which we observe every day. Now there is some plastic item, it looks perfectly fine.
Yeah.
But what is actually happening to these plastics inside it? What happens to the molecules which we can't see?
Yeah, correct. So plastics are nothing but polymers, correct, technologically or chemically.
Right.
So what happens, every material is always subject to degradation. This degradation may be due to temperature, maybe due to chemicals, maybe due to stress, and maybe to presence of oxygen. So in case of plastic, what happens is the UV radiation and oxygens are two important things or two important variables which affect the life of the plastic. So oxygen is typically responsible for its degradation, and that's why some oxidants are added during processing of plastics to improve their life against degradation.
Okay, understood. So tell me something, does the heat or cold, right, does it affect the countdown clock, or does it affect the lifespan of that plastic article?
Exactly. So temperature, as well as some chemicals, as well as some oxygens, they are always responsible for the degradation. Right. So if you increase temperature, then naturally the chemical reactions will increase their rate. So degradation process will be, the rate of degradation will be increased because of temperature. So this is actually fundamental theory put forth by Arrhenius in the 19th century. So every chemical reaction rate depends on temperature. So that fundamental theory can also be used to model the life or to estimate the life of the plastic.
Okay. And how did the scientists identify this? How are they testing it? And how can they find out that, what is going to happen in next decade, maybe 20, 30 years?
Correct. Well, what happens, you can't estimate life directly. You have to take the sample of plastic, test in the laboratory for their resistance against chemical, resistance against temperature, resistance against stress by using UV radiation test or weatherometer test. Okay. Then you will get some results in the laboratory. Right? So that results you have to put in the software. This software is always based on Arrhenius kind of theory. And then what happens? Your results are related to sample, but your product is having some different dimensions than the sample. Correct?
Okay.
So you can use the results of lab. So you have to prepare the drawings of your product by using that software. Then in that software, add the results of laboratory, then you can simulate the degradation phenomena, and then you can estimate the life. That is the general procedure.
And is there any mathematics behind it?
Yeah, there is a mathematics based on Arrhenius theory again. So Arrhenius theory will tell you the rate of degradation will depend on temperature. So it will
Okay.
estimate the constants
Hmm.
of this equation. So any software, if you prepare for the life
Hmm.
prediction, will be based on Arrhenius theory. So number of software you can prepare. For example,
Hmm.
I am a current scientist. I use COMSOL for the prediction of the life of metal. So what I do
Okay.
generally,
Hmm.
I take the sample in the laboratory, take the result, I prepare the
Hmm.
drawing according in COMSOL. That results are put in the COMSOL, and then I get the life prediction or the simulation maps.
Okay. So having this remaining life of the product, right, which
Correct.
is a plastic product, how
Correct.
does it help? How does it help? I mean, you can take an example of, let's say, museum, and there is some plastic art which is there. So,
Correct.
how does it help?
Correct. Suppose if you simulate or if you get some computer model or prediction, then I can take the
Mm-hmm.
measures accordingly. For
Hmm.
example, suppose there
Hmm.
is some process variable like presence of oxygen is responsible for degradation, then I can reduce the
Correct.
quantity of oxygen in that room, or I can take that sample to the, I can take that artifact to a different room which is having different process
Yes.
variables. So these measures can be taken accordingly.
Okay.
Very possible.
So, anywhere else it can be used, Dr. Deshpande, apart from
Pardon,
museums?
where do we use? I
This
can't
kind of
understood.
testing,
Huh.
where else it can be used? Is what I was
This
asking.
kind of testing is used for every material. Only thing, the basic philosophy is same, but you have
Mm-hmm.
to change the machineries and you have to change the variables used in that machinery. For example, when I test the metal, the loading is different. When the same machine I can use for plastic, but the
Okay.
uh, variables are different. That's all.
Hmm. Now there is a mathematics, there is a theory, there are models, there are softwares.
Correct.
All these put together, can we figure out the eco-friendly friendly plastics that can exactly last as long as we need them to last?
No, no, correct, correct. That is very important thing. What happens is modeling and the simulation things. This can be
Hmm.
used for only existing things.
Hmm.
This can't predict the biodegradable plastic. You will need fundamental research for that, and then you can use the model. So
Okay.
this every software cannot be used for the research. What
Hmm.
it takes the data which is available, and then it can predict. That's all. But it can go
Okay.
for the fundamental things. Fundamental
So that
science should
is, yeah.
fundamental
Go ahead,
science,
please. Sorry.
chemistry, polymer science, then
Hmm.
laboratory experiments, that should
Hmm.
be carried out first, investigate that, and then data you
Okay.
can use for the model.
Hmm. Okay. Now there is a very interesting question which comes to us from a lot of students. And one of the students is asking that, I enjoy chemistry and mathematics, but I want to help
Yeah,
environment, right?
yeah,
Is the material science a good career for me in that case? If I want to,
yeah,
help the environment, save the environment
yeah. Very good
with
question.
chemistry and mathematics.
Yeah, this is typically important for the developing countries like India. Correct.
Hmm.
So materials are everywhere. Means you see everywhere you are sitting or you are something using. You are using some bottles. Everywhere there are materials. So material science is
Right.
the basic thing. Even the designs of mechanical engineering are improved. Nothing can be done if the materials are not
Correct.
available. For example,
Hmm.
the space shuttle was possible after 1975 only because the materials were there to fabricate the space shuttle. Okay, if the materials are not there, nothing can be done. Even designs are
Hmm.
improved. So, material science and
Correct.
engineering is a charming career. It can find in industries, in laboratory, in R&Ds,
Hmm.
every sector. You will find material
Right.
scientists. They are working polymer scientists, metal scientists, metals and metallurgists, or ceramic persons. So all these things
Hmm.
they can go hand in hand with the mechanical people and they can design the new systems or new product. So material science
Okay.
is even you can say career for the next century also. In the days of,
Right.
even I will give an example. Even
Sure.
Intel company is having number of metallurgists or metal scientists to
Hmm.
fabricate the chip of the computer.
Yes. Yes. Absolutely. Absolutely. Now, the base question, right? If somebody is interested in material science, or somebody is interested in a very specialized field called polymer stability, so what are the career paths for
Correct.
students?
Correct. So first thing he has to do basic chemistry or basic material science or basic physics. Then he has to
Hmm.
do he has to he her she has to do MSc, then PhD. So in the
Hmm.
PhD, what he or she can select the topic of research. For example, polymer stability that you are talking. So
Right.
he has to select the topic accordingly, and then he can go for the polymer stability or the other kind of
Hmm.
other kind of
Hmm.
problems in the polymer science. And then he can become scientific assistant or research associate in the laboratory like
Okay.
NCL. Number of labs are there, NCL, then CSR labs are there. And then he can take his career to the next level.
Okay. My second last question to you, Doctor. My question is, if somebody is not that kind of, let's say, studious to go and have a patience of doing a PhD, right? Is that okay? Or is there something specialized courses or subjects or short-term
Yes,
this?
short-term courses are available in
Mhm.
Mumbai. Some packaging institutes are there, so there are
Mhm.
testing short-term courses are there. Then some
Okay.
diploma courses in polymer engineering, then polymer technology. There also their degree courses are
Yes.
there, and at a
Yes.
different part. So this is for engineering, and suppose one
Mhm.
has to do research, that is the science he can do. So there are two different things. Either select some basic science
Mhm.
for becoming scientist, or you can become
Okay.
engineer, and then you
Hmm.
can develop or design the new systems, new products based on your what you learned in your course. That is
All this
possible.
is fine. All this is fine. And this is a favorite question of today's students. So where will I get my jobs?
Yeah.
Where
So
will I get the job? If I do all these things, what you just mentioned,
yeah,
where
yeah.
do I get the job?
Yes. Jobs are available in R&D institutions, national chemical
Okay.
laboratories, national metallurgical laboratories, then defense
Hmm.
sectors, then industries like Bharat Forge, then Tata Motors. So all these kind
Okay.
of industries require material scientists, polymer
Hmm.
scientists, ceramic scientists. So
Okay.
number may be somewhat less, but
Hmm.
there are always jobs, and this job, important thing is that these are not replaced by any other branch. These are
Yeah.
specialized things. So the production people or any other automobile people or mechanical people, they can't replace you if you are
Hmm.
specialized in material science. That is the most important thing about the materials.
Okay, so that's all for now. And then Dr. Deshpande will come and meet again on a
Yeah,
specific topic on corrosion,
correct.
which is your favorite one. So thank
Yeah,
you very much for joining us. See
yeah.
you then. Thank you.
Thank you, Virendra, and Dr. Patik sir also for inviting me.
Thank you so much.